I've got my first 4 electrons easy. Now electrons 5 and 6, I'm going to go here and then here. And trust me, this is going to be a big deal in chemistry for the rest of the semester. So this is one form of electron configuration, and I love it because it's a pictorial model of where the electrons are located. And trust me, this is going to be a big deal in chemistry for the rest of the semester. So there are 3 rules that we need to know for electron configuration. First is Aufbau, and this is a rule of starting to add electrons at the lowest energy level available. And so what that means is always start at 1s. Remember, that's our lowest energy level. And then we're going to start filling those energy levels as we go on up through that progression. And this is the order in which the orbitals are filled. Now, that looks a little complicated, doesn't it? Well, hang with me. We'll get to a shortcut in the next video. The next one is Pauli's exclusion. And so this rule is we want to put a maximum of 2 electrons in each orbital. And if you do have 2 electrons in an orbital, they need to have the opposite spin. Now, what in the world is an electron spin? Don't worry about it. Let's just say if we had in the 1s orbital, if I were to show 2 electrons, I would show an arrow up and an arrow down, meaning opposite spin. And that's how we note that. The next one is Hund's rule. We're going to maximize the number of unpaired electrons in equal energy orbitals. And what this means is, I'll show you that when we get to an example. So let's go ahead and start doing orbital notation for the first few elements. So the atomic number of these, hydrogen, helium, I'll just write it to the side. So this is atomic number, and that's how many electrons we have in each of those atoms. So that's how many electrons we need to put in our orbital notation. So the first thing that we're going to do is our first orbital is the 1s orbital. And so hydrogen has only 1 electron. And so let's represent that with a half arrow. It doesn't matter up or down. That's it. It's done. The next one is helium. Where do those 2 electrons go? Well, we can put 2 electrons in the 1s orbital. So let's put them both in there. One is spinning one way, one the other way. 2 electrons, done. So the next one, well, let's see, we've got 3 electrons. Where do the first 2 go? They go in the 1s orbital, and that orbital is now full. So we've got to go to our next orbital available, which is the 2s. So I'll draw the 2s, a little space in between. And then I'll put that 3rd electron there, and I like to just do a half arrow up. So there's 3 electrons. Beryllium, we have 4 electrons. Where do you think the first 2 go? That's right, in the 1s orbital. And then the last 2 are going to go in the 2s orbital. Okay, can you see that each element we are adding 1 electron? And so every element is just 1 electron fuller than the one before it. All right, let's keep going with elements number 5, 6 through 9. All right. Boron, we've got, we're going to start off with the 1s, 2 electrons, and then the 2s. Okay, now where does that 5th electron go? Well, now we're up to the 2p orbitals. Now, we only need 1 of those p orbitals, but we always draw them all because they occur always together. There's always 3 p orbitals overlapping. And then we just want to put that 5th electron right there in that first orbital. Okay, carbon is going to look a lot like this, but we only have 1 electron more. So I'll draw my 2p orbitals. Now, watch this. I'm going to show you an example of Hund's rule right here. Okay, we want to maximize the unpaired electrons on equal energy orbitals. So that's the situation we have here. So I've got my first 4 electrons easy. Now, electrons 5 and 6, I'm going to go here and then here. So see, I have 2 unpaired electrons in those orbitals. Now, nitrogen, similar. Okay, now this time I've got to put 3 electrons in here, and there we're going to space them out. 1, 2, 3. Okay, so I like to relate Hund's rule to this. If we're going somewhere on a bus, right? you're not necessarily going to sit with someone on the bus unless the bus is full. So everybody's going to get their own seat on the bus unless you have to start to double up. And so that's kind of the scenario with Hund's rule. All right, let's do oxygen. We've got 8 electrons, and it's looking pretty familiar, isn't it? So here's my p orbitals. Now here we go. I'm going to change colors so you can see these. So I've got 4 electrons accounted for. I've got 4 more. Here they go. Here's number 5, 6, 7, and number 8. We doubled up, right? We had to, right? Because now we have only 2 unpaired electrons. All right, let's do fluorine. It's going to look a whole lot like oxygen. 1s, we've got 2 and 2s and 2p. So I've got, let's see, 4 electrons. I've got 5 more. Let me change colors so you can see them. So there is 5, 6, 7, 8, 9. Okay, and so number 10, that would be neon. Guess where that 10th electron is going to go? Right there in that last p orbital. So do you get the idea of how to do orbital notation? Let's do one more. Let's do a big one. Let's do gallium. All right, I've got 31 electrons. Here's my order. Okay, so I'm going to start off with the 1s orbital. I've got 1, 2, and then the 2s. I'm going to go ahead and get ahead here. I'm going to draw some of these. I know I'm going to need a bunch of these orbitals. All right, so I've got 2 electrons, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, I've done 18. I've got a few more to go. I'll make a note right there just so I won't forget how many I've done. Okay, I am up into, I've done the p orbital. Now I need the s orbital. So there's my 4s. What's going to be next? 3d. Okay, these are 5s. Let's put these in there. So there's 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 electrons. Now what's next? I am now to the 4p. Okay, I don't have any more room, so I'm going to draw my 4p's down here. Draw them all. I'm not going to need them. That electron right there was number 30. I just have one more to go. Where's that last little electron going to go? There's number 31, all by himself in the 4p orbitals. Now, it's a little bit tedious, but some of my students find it kind of therapeutic just to draw these things out. So grab a couple of these and follow this order. You will definitely need this order right here in doing orbital notation. I hope this helps. You can do this.